Hello, welcome to Topper Machine. I'm Josh Topper, and today's job is a little bit of a different one, a little more involved, but this is a cylinder trunnion. This is actually the head of the hydraulic cylinder, and this is a mounting trunnion, and as you can see, it is extremely wore on both sides. So what we are actually going to do is, at the request of my customer, is to turn these down and sleeve them, and then remachine them to size for the bearing that goes on there. All right, so what I'm going to do first is I'm going to make my sleeves, and I'm actually going to make them oversized. We'll finish machining them after they're on the trunnion. But we're basically just going to do the bore. We'll drill it and then ream it. Make sure it's good and cool when we ream it so it's to size. And then we'll cut off the pieces we need, probably a little extra long so that we've got, material to clean up at the end. And then we'll chuck up the trunnion in the 4-jaw, turn the one end, flip it around, put it in the 3-jaw, and turn the other end. All right, so here's our bushing, and now remember, reaming is not without its faults, especially on a horizontal spindle like that, because I'm already 7 thou over what the reamer was, so that was an 875, which is not going to hurt me one bit, because we're actually going to turn the stub on that oversized, heat this up, slide it on, cool it, and then finish the machining on it. So it'll be a sweat-on fit, nice and tight. But what happens when you're running a horizontal spindle like that is crap gets in there and it causes it to move around, and it's for the most part it's very smooth, but it's still not perfect. So you don't want to rely on that, you know, for finished bore on some stuff, but for this is absolutely perfect. All right, so I got the forge on the lathe and I'm looking this thing over, and this side's really bad. This side's not so bad, and it looks like I'll be able to indicate off this very end here to get it as true as possible, but it's pretty square, so it'll sit in there. Once I just get it in the jaws, it should sit in there good. And another way to do this would be on the milling machine with the boring head, but I prefer the lathe. And there's so much better ways of doing some of this stuff in the lathe than there is on the mill. So I'll go ahead and I'll get this set up and then we'll start machining. So there's no really good way to do this because there's so much wear on it, but I'm on that outer edge, and for the most part I'm holding right about zero most of the way around until I get right in the really war spot. Then it's all over the place, but it really doesn't matter as long as it's true and square, and it should be because the way it's gripping in here. So we're going to just turn down this OD oversized to what our bushing is, and then we'll flip it around and put it in the 3-jaw and chuck up on this part and turn the other one. So it actually doesn't look too bad. So I'm going to come in here, just touch off on the back end. And that's all the deeper I want to go back there. Take 40 thousandths to start just to see where we're at. Take a quick measurement here, just see where we are. And this side really wasn't that bad, so 925. Still didn't clean up 100%, so it was pretty wore. It's a 25 millimeter to start with, so we got a little ways to go here. We're taking it to probably go to 887, and that'll give us a nice tight fit when we heat it up and slide it on. All right, we're just going to take another 40 or 20, I mean, just clean it up, and then we'll get a good measurement, see right where we are, and then finish this side up. I'm just going to stop short because I do want to leave a radius in there. .904. So that leaves us 17 to go. I'm going to take 15 and we'll just check it. We're not going to go too far in, but we'll just double check our number or our measurement a little ways in. That's far enough. .89, so we could take that 17. We'll do that. .887, right on, right where we want to be. Now it won't go on, but we'll be able to heat it up and slip it right on there. So I got thinking about it, how 887 is awful close to 875, and how a collet will grip this a lot more safely. We're not taking a lot off. That I could just use the collet chuck to support, to do this side so we don't mar up our finish. And I think this will work out extremely well. Spin it up and see how it looks. Boy, considering all the wear on that shaft, it actually is looking pretty good. And these are spherical bearings on here, so this really isn't that critical, but I want it to be right. All right, so I'm just going to touch off here. Come out and see, but I think, yeah, we basically got 100% cleanup, just that little bit I touched it, so we are dead nuts on. So we'll go ahead and take our first cut here. I'm actually taking about 60 thou off of the overall diameter. Yep, didn't even touch there, and I don't know that we're gonna get that 100%, but it's okay. It's still gonna have something holding it, so. We'll leave the last 17 thousandths, or actually maybe more than that. We'll leave more than that just so we're safe. And the last pass. Considering the way the other one cut, I'm not going to get too concerned about measuring it. And we are getting in enough in the high spots to make contact, so I think we will be okay when we machine this all the way down. All right, so I'm back here in the weld shop. I got it on the arbor press here, and I've got my bushing sitting right here. What I'm gonna do is get this good and hot with the torch, pick it up like so, and put it on. And with any luck, it'll expand enough to drop on. It's only about 5 thousandths, but if not, I got the arbor press ready to go to just give it that final push and drop it on. Man, that did not want to start. That was a little nerve-wracking there, but it slid right on with the press, so we'll let that side cool and I'll flip it over and I'll do the other side. All right, so I'm going to do this one a little differently. I've got it flipped upside down. Seeing as how the bottom being down on the cast plate there didn't get too hot, I'm going to try to see if it'll start better this way, getting this side hot. There, that went on. Just took a little coaxing. All right, we're back in the shop. It's all cooled off, and there it is. Now, if you remember right, I cut them a little long so I could face that difference off, but boy, they look good on there. So we're just gonna chuck these up on the 3-jaw. Just gonna grab this, turn one end, get it all down to size, flip it around, turn the other end, everything will be in line. All right, so the first thing I'm going to do is touch off and get my length, or my distance in where I'll stop for cutting. We'll just touch that right there. Zero the readout, and we'll come out. And that stub was just an inch long, basically, so we'll just go ahead and just face this down to a little at a time down to that inch, just to make sure. I bet it was 25 millimeter actually. Yep, it was 25 millimeter. So I was noticing a little bit of wobble there while I was turning it, so I'm just going to center drill and put a center in there just to stabilize it a little bit. A little of our anchor lube on there. Now we should be able to take our first pass. And I'm not going to take heavy passes just because of what we're doing here. Just want to go carefully at it and not worry about screwing it up. Get a rough idea where we are with the caliper. 1/200, and we're going to 25 millimeter, which is 0.9843. So actually we're going to go to 985 just to have it a snugger fit. We've got at least 200 thou to go. We'll take that at 50 at a time. So I took 190 and I'm with the caliper, I'm 1/112. So I've got another 25 plus to go. Sorry about that, my camera battery died and I didn't get that last cut. I'm just going to chamfer it here with my threading tool a little bit. And we are right at size. So this one is done. So we'll go ahead and turn it around and do the other end. And we'll do it the exact same way. I'll center drill it. Center drill it for support, and look how nice that came out. Center drill for support, and then we'll do the machining. Let's get a measurement, see where we're at. $9.98. So we've got 14 to go. I'm going to go ahead and take 13, and we'll just polish it in. Actually, we'll take 12 just to be safe. That might have done it right there. $985. Just a touch under $985, which is perfect. That's what we were after. I'll just take my threading tool here and just put a little chamfer on the end, and we are done. Well, there you have it. Bushed out so that the bearings will fit it nice and tight. And you're probably wondering why we would do a job like this. Why go through the work to just repair that little bit? Well, the cylinder that this is part of is close to $3,000 for the customer to replace it. And that's a huge expense. A repack, and to do this work, you're looking at $500-600. Maybe less, maybe a little more, depending. I don't think we needed to do a rod, so it's probably going to be less. But it's a 36 millimeter rod, a 50 millimeter bore, and like I said, close to $3,000 for them to replace it. So to rebuild it and repair this part is a huge savings to the customer, and they're very happy that we were able to do this. So I hope you enjoyed the video, and with that, until next time, get out in your shop and get it done right the first time.